you have suppliers, right? You're receiving the goods and you're going to pass them on to your customer. So you're setting a standard, an inspection standard, a quality standard that needs to be met. But if you're looking at a lens one way and your supplier is looking at the lens in a different way, you're not congruent. You're not able to, you're not matching up. So when you actually look at your quality results, you're going to say, these aren't matching up. I'm inspecting for tolerance XYZ, and you're inspecting for on time delivery. Two totally different inspection criteria. So we want to make sure they're congruent and we're looking at the same thing. And that's again why we have these collaborative workshops. We understand what the requirement is. And then from that, we then build out our processes, our testing processes, our protocols. And if we have any issues, we talk about that. That's in dispute prevention. What happens when there is an issue? How do we verify it and make sure that it's good to go? Okay, here are different methodologies that we have for congruence testing. We want to make sure we have a good system, acceptance rejection history. What we need history for is to make sure that we can follow that process. Now, again, the reason we want to have history is if we're consistently inspecting and we're always inspecting, what we can do is troubleshoot back to where things started to go off kilter, right? So if we're inspecting, we got 100 items good to go, 120 items good to go, 200, they're good to go, but not quite right. 250, they're good to go, not quite right, but a little less right. 300, now we're getting a little less. I was like, okay, what stop? Things aren't happening. Quality's not quite right. What does it need to be? Let's go back to when we really started to see quality start to kind of go downhill. We look back in the records and we find out, bam, that's when quality started to change. It started to degrade. As a result, why? What was that? Did we have a new piece of machinery that wasn't calibrated? Was the calibration out of whack at that time? Did we get a new employee that had to be trained and they were not trained correctly? Did we change suppliers further down the supply chain? So now we're getting new product that is not meeting standards, and now that's starting to feed its way all the way down the supply chain. We're starting to see that. So we can troubleshoot back. But if you don't have a quality inspection system, and you're not maintaining records and history, you're not going to be able to do that troubleshooting that needs to be done, right? What is the testing capabilities, the different workers? We talked about training. What are our quality systems, machines, calibration of the machines that we're using, Six Sigma, CPK. We talk more in depth about that in the CPSM training. So if you want more information, make sure you go back and look at that training that you need to do. Process control and statistical process control. Now, what do we talk about process control and statistical process control? Just as I mentioned with the ISO, it's all about processes, mapping processes and collecting data about the processes. So when we have process control, we have a process that's mapped out. We're measuring data along that process, and we're able to make decisions based on that process and the data that we're seeing. That's process control. Statistical process control is based on the results of the data. We're now making more informed and better decisions to ensure quality of the deliverable. And we're using statistics and data now to drive those decisions. At first, it was let's make sure we had a process and that's working. Now that we have a process and it's working, let's make sure we can make that process even better, even better. So, introducing the statistical process control, we do statistical monitoring. We can do control charts. What does a control chart look like? If you look at this picture and what this guy is looking at right down here, okay, and you see these kind of squiggly lines going, that is a process control chart. What's happening is somewhere in the manufacturing process, there is a sensor that is collecting data. Sometimes it's really good, sometimes it's not so good. It's just going right there. And what happens is you establish controls to where as you're collecting data and you're receiving things, there are imperfections. There's always imperfections. Nothing's 100% perfect, right? And so you have the range of control. So long as it's within the range, everything's good to go.